Welcome back to the Learning Studio. You're watching our mathematics series, and we're continuing in our section on cryptography, security, and emerging fields. If this is your first time here, don't forget to follow us by clicking the link below, and the full playlist is in the description so you can explore every episode step by step. Today, we're entering the fascinating world of abstract algebra, the study of groups, rings, and fields. These structures may sound abstract, but they're the backbone of cryptography, error correction, and coding theory. Picture this. You send a message across the internet. It has to stay private, arrive without errors, and be verified as truly yours. Behind the scenes, your data is being transformed, checked, and secured, all thanks to abstract algebra. What once seemed like pure abstract mathematics has become the language of security in the digital age. Core concepts explained simply. Here are the essentials. Groups. A group is a set with an operation, like addition or multiplication, that follows simple rules. Groups describe symmetry, from the rotation of a square to the structure of encryption keys. Rings. Rings expand this idea, combining two operations, like addition and multiplication. They allow us to build algebraic systems used in modular arithmetic, which underlies cryptography. Fields. Fields take it even further. They are rings where division is possible, except by zero. Finite fields, also called Galois fields, are critical for cryptography and error-correcting codes. Applications. Groups help design cryptographic protocols. Rings structure modular arithmetic for secure communication. Fields enable error correction in CDs, QR codes, and even deep space communication. Why it matters in AI, security, and technology. Abstract algebra is not just a mathematical playground, it's deeply practical. In cryptography, group theory underlies RSA, elliptic curve cryptography, and digital signatures. In coding theory, finite fields allow us to detect and fix errors in noisy channels. In computer science, algebraic structures organize algorithms and data. Even in machine learning, symmetry groups are used in geometric deep learning. Abstract algebra is the hidden architecture of secure communication and reliable information transfer. So, abstract algebra transforms pure logic into applied power, from securing your bank account to making sure a spacecraft can send a perfect signal back to Earth. In our next episode, we'll move into category theory, the mathematics of connections and structure. It's a unifying language that powers functional programming, composability in machine learning, and even the way we think about abstract systems. Don't forget to follow us by clicking the link below and check out the full playlist in the description. Each episode reveals how mathematics not only explains the world, but also secures and builds the technologies of tomorrow.